Hey guys, I'm back again to go over another AP Physics 1 free response question, and this time we'll be taking a look at the fifth question on the 2018 AP Physics 1 exam. So in this question we're given that a spring with the mass attached to it, initially just mass m, is going to collide with another mass coming from the top of mass 2m. So in the first question in part A, we're asked to find the period of the new system compared to the period of the old system. Well, we know that the period of a spring oscillating with the mass attached to it is going to be equal to 2 pi square root m over k, and that if we increase the new mass to 3m, it'll be 2 pi square root 3m over k. And since everything else in this system is the same, we can just divide the two and get square root 3. So in the second part, we're asked to find whether the amplitude of this new system is going to be greater than, less than, or equal to the amplitude of the old system. And this question actually requires a lot of concepts such as conservation of momentum and kinetic and potential energies of a spring. So let's just get right into it. So when we first look at the conservation of momentum equation, we're going to get that m1 times velocity 1 naught plus m2 times velocity 2 naught is going to be equal to m1 times velocity 1 final plus m2 times velocity 2 final, right? And if we just look at the top, we find that certain values such as m2 velocity 2 naught is going to be 0 at the start. We can just cancel that out. And if we want to find the right side of the equation in terms of v1 naught, we can just simplify that out to be m1 times v1 naught is going to be equal to m1 v1 final plus 2 times m1, and we know that the system's going to be moving together, so this will just be v1 final as well. And simplifying this out, we get m1 times v1 naught is going to be equal to m3m1 times v final. And if we cancel out the m1s, we get v1 naught is equal to 3v final. And so the second part of this question requires us to do kinetic energy, where the kinetic energy at the maximum point, which is where the spring is at equilibrium, is going to be 1/2 mv squared. And since we found in the equation above that v1 naught is equal to 3v final, or v final is equal to 1/3 v1 naught, we're going to be able to say that the equation of the first system is going to look like 1/2 m times v1 naught squared, while the equation of the second is going to be looking like 1/2 times 3m times 1/3 v1 naught squared. And this will simplify out to 1/6 m times v1 naught squared. So we can clearly see that the second one, is going to be less than the first one. And if we consider that the potential energy at the point very furthest from the equilibrium, or where amplitude is at the maximum, is just going to be the entire energy of the system, we can compare this to the potential energy, which is 1/2 k squared. And we know that if the equation above, the left side of the equation above is greater than the right, then the equation below is going to follow the same principle. So we know that a1 is going to be greater than a2, because these two are constant. So the new one is just going to be less than. Alright, that was it for today. Thank you for watching, and I hope to see you in the next one.